Good morning and welcome to today's webinar, I3C Protocol Application Layer Testing and Conformance. My name is Pranav Jagdish and I'll be your host for this technical session. We have two esteemed presenters with us today, Mr. Godfrey Coelho and Ms. Shweta. Godfrey has over 25 years of experience in the test and measurement industry, and Shweta brings over 8 years of experience in the I2C and I3C protocol validation and automation. In this webinar, Godfrey and Shweta will provide an overview of I3C protocol adoption, discuss application layer protocols such as MCTP, SPDM, PLDM, and NVMe-MI, and highlight the challenges in application layer testing and conformance over I3C. They will also demonstrate Prodigy Technovation's PGY I3C EXPD protocol exciser and analyzer, explaining its key capabilities and practical workflows for I3C application layer testing and validation. We encourage you to participate actively by posting questions in the Q&A window throughout the session. The last 10 minutes of the webinar will be dedicated to answering your questions. Please note that the webinar is being recorded and a link to the recording will be sent to all attendees afterwards. So if you experience any connectivity issues, you can catch up later. Without further ado, I would like to hand over to our first presenter, Godfrey. Over to you.
Hi everyone. Thank you for joining this webinar. Really appreciate taking out your time and attending this event. So my name is Godfrey Coelho. I'll be one of your presenter. I take care of the sales and product management within Prodigy Technovation. I've been joined by Shweta. Shweta is our lead for quality management, and she has been involved with I3C over the last 7-8 years in testing and customer support. And she will be taking over the demonstration of these products. So today, this webinar is about I3C, MCTP over I3C, NVMe-MI management interface, SPDM and PLDM protocol validation and conformance test suite. So agenda for the today's webinar is very briefly, we'll talk about Prodigy Technovation, I3C specification evolution over a period of time, and the binding protocol for different application layers, MCTP, management component transport protocol over I3C. And then we talk about NVMe, MI, SPDM, PLDM protocol overview, and its conformance test suite. Okay, what are the different test cases? And then we follow up with a detailed demonstration of I3C, MCTP, NVMe, MI, SPDM, and PLDM, including the CTS. So about Prodigy Technovation, we are almost now 15-year plus experienced in protocol exerciser and analyzer development. So our products are adopted by global semiconductor companies across the globe. We have customers in Japan, Korea, Taiwan, China, India, Europe, and US. So we are based out of Bangalore. We are headquartered in Bangalore. All the product development activity takes place in India. These are made in India product. And we have a branch office in US where we are supporting our global customers in US with a direct sales presence. We do have distributors in Japan, Korea, Taiwan, China, Germany, Italy, Israel, Netherlands, and Southeast Asian countries. So we request you to visit our website in case if you're interested in our product and reach out to them so that they can provide you all the technical and support information. Our expertise is in ultra high speed product development, and we do the complete hardware, FPGA logic and software development. These are fully in-house products which we are developing, which enables Prodigy Technovation to support our customers extensively and also provide the upgrades as and when required to the market. We do have a range of low-speed protocol exercisers and analyzers to support the low-speed protocol validation. And then our solutions are includes PCIe, UFS, I3C, SPMI, and many more. So we have two product categories. One product is protocol accessorizer and analyzer, which is a standalone product, which is our own hardware with the software and everything probing solution. So we start with a simple product like I2C and all the way up to PCIe Gen 5 protocol analyzers. We have a range of I2C protocol exercisers and analyzers like SM bus, PM bus. In I3C, we will talk about in detail in the upcoming present slides. And the SPI, we have SPI, QSPI, eSPI range, which we support both protocol exercisers and analyzer. And for the flash memory, we have for eMMC, SD, SDIO, SD UHS2, SD Express, and OSPI and XSPI and UFS 4.0. And if any one of you are working on UFS 5.0, please contact us. So we have a protocol exercisers and analyzer for many of the flash technologies. And then PCI Express up to 32 Gbps protocol analyzer also we are supporting. So these products provide the capabilities to you to generate different traffic, error injection, vary the timings so that you can validate your protocol to the full specification of the product. Okay. The second category of product what we are offering is a protocol decode and electrical validation software. This is an application software which takes the oscilloscope acquired data as an input to the software and it analyzes for protocol decoding and errors in the presence. And also some of these softwares also support electrical validation. So we support Tektronix, Keysight, and Teledyne Lacroix oscilloscopes, which can take this data and does the electrical validation as well as protocol decode. We support both node locked and floating licenses using USB key. So this provides a complete product overview. And if you are interested in any other technology for protocol exercisers and analyzer, please do contact us. So some of those new products are in our roadmap. We can discuss with you. And some of them based on your need, we are also open to develop it for you. Now, coming back to the I3C protocol, so I3C specification overview, we can here look at how I3C specification is evolved over a period of time. So I3C specifications first launched way back in 2016 by MIPI Alliance. MIPI Alliance is driving the and defining the specification, maintaining the specification, and providing all the necessary support to make sure that I3C technology is successfully adopted by conducting interops at regular intervals of time. In 2016, I3C 1.0 specification was released with a maximum clock speed of 12.5 megahertz with one lane. It had capabilities of in-band interrupt and enhanced data rate like HDR. It's like double data rate. So you can get 25 Mbps at 12.5 megahertz clock. And then they also had some of the efficient encoding technologies like TSP so that you can still get more data throughput. It is only available for the MIPI Alliance members in 2016. And based on the need, the main purpose of I3C specification was providing a one consolidated interface to support the wide range of data and also at a low power consumption and mainly to trying to provide a equivalent performance for I2C, SPI, and UART. Now, these three technologies are widely adopted and it is freely available anyone who want to use them. And in order to enable the entire community, the MIPI Alliance has released the I3C Basic Specification 1.0 in 2018. It is a royalty-free specification for non-MIPI Alliance members, and it actually not supported some of the high performance features like HDR, TSP, TSL, and timing mode, but it provided a very enabled a roadmap for wider adoption of I3C specifications. Okay, so in 2018, so all the engineering community could access this specification. And 2019, I3C MIPI Alliance announced a I3C version 1.1 spec where they introduced bulk transfer mode in HDR. Also, to increase the data throughput further, there is also introduction of a multi-lane configuration where you can send the data on 2 lanes or 4 lanes, so going a data rate up to 100 megabits per second so that it can serve the many of the applications. And also it introduced to target reset features, device to device tunneling. Again, I3C version 1.1 specification was accessible to MIPI Alliance members in 2019. Okay. So over a period, again in 2021, MIPI Alliance made some improvement to the I3C specifications to support 1 volt voltage range. And also it announced the I3C basic version 1.1.1 specifications release. Now with this specification, the gap between the specification for MIPI Alliance member and non-MIPI Alliance member is significantly reduced. Now there is a access specifications access for HDR, bulk transfer, timing control, group addressing. All these specifications are accessible to MIPI non-alliance members. So over a period of time, because of the specifications, enhancement and improvements, so I3C has been adopted in CXL, in JEDEC specifications like SSDA for a sideband signaling, and some of the optical communication links. So it is being used in many different applications for sideband communication purpose. In year 2024, I3C made some more upgrades to the specification, and 1.1 is released. There is no change in the protocol, but some of the timing specifications are updated to make sure that the I3C technology can be used in a wider range of applications, and the error handling and recovery timings are also clarified to the adoption community. So this gives a overview of I3C specs, how it is evolved. There are Prodigy Technovation also conducted on the protocol seminars. You can access some of our webinar and know how the protocol works. So the application layers of protocol layer over I3C are many actually, because it offers the benefits over the legacy I2C in terms of the throughput and the low power consumption. So in order to enable different application layers, so there was a need for a binding protocol, and DMTF has introduced a MCTP protocol, that is Management Component Transport Protocol, to accommodate this requirement. This is a message-based protocol, enables a communication with controller and multiple targets, and MCTP over I3C provides a higher throughput as well as low power consumption because of the I3C protocol and electrical performance. And now, in order to support different use cases and the requirement, DMTF also introduced SPDM and PLDM protocol, and then the NVMe working group also introduced NVMe-MI protocol, which is also available, but it is now made available over I3C so that I3C can be used as a sideband signal in the storage components. So while this I3C specification is improving and developing, Prodigy Technovation has been continuously offering the different test solutions over a period of time. In year 2018, we launched PGY I3C Exerciser and Protocol Analyzer version 1.0. It provided a capability of generating the SDR and HDR, hot join, IBI capabilities. Plus, it also offered error injections, varying the amplitudes and timing parameters so that you can do the margin test of your device under test. It supported both the controller as well as the target capabilities in one single hardware. Then there are also a group of users who wanted a simple and lighter product at the half the price of the PGY I3C XPD, and we launched that product in 2019. It almost had a similar capabilities, but less design margin testing, and it was a fixed voltage operations was supported on that. Now, for all the production testing and the volume testing purpose, Prodigy Technovation introduced USB adapter, I3C USB adapter in 2021 at almost one-fourth the price of PGY I3C EXPD. And in 2021, the MIPI Alliance launched the I3C Conformance Test Suite, and we also supported immediately with the option CTS to Prodigy's PGY I3C EXPD product so that you can do a field upgrade of it and you can do the testing of the I3C protocol. At the same time, Prodigy also launched a I3C protocol analysis capabilities within our analyzer, which is at a very, very low price point. So you can do a complete I3C protocol. And we also supported multi-lane I3C protocol decode, mainly to take care of DDR5 adoption, where there is a need to monitor multiple I3C lanes at the same time. So in 23, we announced the MCTP and NVMe-MI support, and 2025 we added the burst mode and multi-lane. And based on many users wanted to use this product on Windows, Linux, and Mac OS, and we launched the new software in 2025 August, so that it becomes a can be used in a wider use cases. We also enhanced the software UI for easy use and more better look and feel. And then we launched the full NVMe-MI compliance for the target. And now we have a solution for SPDM and UNH. Today, during the demonstration, we will try to give you a quick overview of different test solutions for all these technology. If you look at MCTP protocol, because it is a embedded or encapsulated within the I3C protocol, and whenever the slave has some data to communicate with the controller, so it will send an IBI interrupt with the mandatory data byte 0xAE value, and based on that, I3C protocol will start sending the broadcast address, and then it will send the source destination address, and will try to read the data, and that data which is reading from the target is a MCTP packet. Now this MCTP overheads are shown in this slide, which has a version number, the destination endpoint ID, the source endpoint ID, the start of message, end of message, the sequence numbers, tag, so that you can know the sequence of the messages coming in. And also then there is a message type, because within MCTP, it is defined such that we can embed other application layer protocols, and this will be somewhere in the message type and message header and message data with a message integrity check. And at the end, there is a peg to make sure that data integrity is maintained, where the controller can make sure the received data is perfectly valid and take the necessary action. Now, when users or engineers develop the firmware for MCTP, they need to make sure that it is conforming to the MCTP specification. Now, in order to ensure this kind of a functionality, the University of New Hampshire has provided a conformant test cases, almost 15 test cases, where user can inject these test cases to the device under test and see whether they are compliance to MCTP specification. So these are the different test cases like MCTP endpoint, the pad packets, 1, 2, 3, 4, 5, then different MCTP commands it can send, so that we can make sure that the firmware is fully compliant to the MCTP, so that when you develop a product, it will very efficiently interoperate in a system level use cases with the different controllers as well as with the targets. Okay. So Prodigy Technovation offers the test solution within our I3C protocol exerciser and analyzer. The NVMe-MI protocol is a protocol from NVMe working group, which mainly used for SSD outside the normal data path. It uses the I3C interface as a sideband signal and drives the NVMe-MI protocol on top of it using MCTP. Okay. And then you can look at do the out of band management of the operation of SSD, even though the host OS and the NVMe drive is not running, so that you can upgrade the firmware. You can also bring up the SSD with all its capabilities, and also you can continuously keep tracking, monitoring the NVMe devices in a cloud storage environment, because this is a very reliable operation of the cloud storage is required, and without a power shutdown, a continuous operations to provide the best services. And I3C with a higher data rate and a lower power consumption provides the flexibility to upgrade the firmware and make sure that the whole network storage cloud storage is working more efficiently. And the NVMe messages are encapsulated within the MCTP packets. So this is a typical MCTP packet, and we can see here NVMe packet is encapsulated in MCTP packet payload. Okay, and all the different NVMe commands and the packet format, everything you can see during the demonstration, because Prodigy's I3C EXPD has a capability to script in NVMe-MI, and also we support all these conformant test suite, which is provided by UNH. These are all the mandatory test cases for NVMe-MI, and we are supporting them, these test cases for I3C. So there are NVMe error handling conformant test cases, NVMe management interface test cases, message processing test cases, and control primitive test cases, and management interface commands test cases. This provides almost around 25 to 30 mandatory test cases, which are part of the NVMe conformance test suite within Prodigy's PGY I3C EXPD. And user can simply select these test cases and make sure that the firmware engineers have implemented NVMe-MI operation within their targets or controllers more effectively, so that when the devices are connected to the in the system level environment, they all interoperate without much difficulty. Another application layer protocol is a SPDM protocol, Security Protocol Data Model. So it is for the secure communication between the devices. It also checks for the authentication, attestation, and secure sessions. So encrypted messages can be sent from the controller to target and vice versa to make sure that the data is very secure and it is not used for any other purposes. So this provides a very powerful solution when the data needs to be secure, because today in the current world the data is lot of personal data is also being used, and this data needs to be handled with a high security where it is stored in the storage. And so when we read and write into it, we need to make sure that the entire protocol is secure for operations. Now, SPDM messages are also encapsulated within the MCTP packet, since MCTP is a binding packet between the application layer protocol and I3C, and SPDM packets are placed at MCTP packet payload with a message header and message specific header fields and the integrity check, so that it works efficiently. In our product during the demo, we will show you all the details of the SPDM protocol so that you will understand what are the different fields within SPDM. Here are the different test cases again for making sure that SPDM protocol is implemented by the firmware engineer more efficiently. So you can test your firmware by running all these conformance test suite. There are almost 80 to 100 different test cases which are mandatory in nature, which will check for the capabilities, algorithm, certificate, authentication challenges, and key exchange, and all this purpose, the health of the target, as well as update of the key. So all these test cases can be run from Prodigy's I3C exerciser and protocol analyzer, and you can validate your firmware to make sure it works efficiently in the device under test. So the one more protocol, which is a platform level data model protocol, which is used for in place of a IPMI. So in the going forward, and it will be used for communication between the sensors, fans, all the different parts of the system to make sure it works reliably. It enables the communication between different hardware and firmware components, regardless of the vendor. So making sure that it is more effective. Again, PLDM protocol is defined and managed by DMTF, group of industry association companies, which are driving this specification, which also provides a low latency and low complexity interface, consumes less power based on the I3C. It is also can be used for monitoring, configuration, firmware update, and diagnostics. So all these capabilities can be leveraged by adopting platform level data model protocol. So the PLDM protocol is encapsulated within the MCTP packet payload. And these are the different attributes of the PLDM protocol. So our PGY I3C EXPD supports PLDM scripting, and we can drive different traffic from the controller and test the DVT's firmware is operating efficiently for the PLDM protocol. So we will provide you a detailed demo after this for you to know exactly how this product works. Over to Shweta.
Thank you, Godfrey. I'm Shweta. I will be presenting a demo of PGY I3C EXPD along with the higher level application protocols built on top of it, such as MCTP, NVMe-MI, SPDM, PLDM. I will also showcase a conformance test suite available in the PGY I3C EXPD platform. So this is how the improved graphical interface looks like. The software is designed as a cross-platform solution supporting Windows, Linux, and Mac OS. It also provides API support across major programming languages, including Python and C++. So let me begin by explaining the hardware setup. So the hardware unit is connected to the external I3C target device using a probe cable. The Prodigy unit is connected to my host system via USB 3.0 cable and powered with a 12-volt power supply. So once the connections are done, I'll click on check hardware connection. So now I will configure the device in the network. So for this demo, I will be using internal Prodigy controller and an external target. So to add a controller, I will select the node type as controller and interface as internal. Since I am using the Prodigy controller, we have a termination option where user can either disable or enable the programmable pull-up resistor based on the setup. So I'll keep it as on. Then voltage. So here you can enter the voltage level from 0.9 volt to 3.3 volt in step of 50 millivolt. So I will be entering it as 1.8 since I am operating the target at 1.8 voltage. And trigger mode. The hardware supports both trigger in and trigger out mode. Then I'll click on add device. So now the controller has been added to the network. So now I will be adding an external target device. So in that case, node type, I'll choose it as I3C target and interface as external because I am using an external target device. And again, the termination, I will keep it as on. And then I will enter a unique static address of the target. So I will be entering the 6B because the connected target device will be in the I2C mode default. Once the dynamic address is assigned, it will switch to I3C mode. So then the voltage, I'll enter it as 1.8 volt. Then click on view registers. So this window, we will get the different BCR, DCR and PID values. So different register settings we can see here. So user can select any of these selections. So I will be setting the BCR bit to BCR bit to limitation as per the target. And then I'll choose from the DCR list, I'll choose the Accelero Gyro combo. And then coming to the provisional ID. Here you can enter here you can select the manufacturer ID. So from the drop down list, so I have connected a general purpose I3C target from ST Microelectronics. So I'll be choosing the ST Microelectronics. So if the target is not listed in the manufacturer ID, user can go to custom and enter the custom manufacturer ID. Then user can enter the unique part ID, instance ID, and the vendor ID of the target. Yeah. I'll click on close and add device. So now if you go back to the network and if you see one internal controller and external target is configured. So in the network, we can see the dynamic address currently is not assigned to the target device. So next click on start capture, basically to start the acquisition mode. Then click on config controller. So then click on controller to exercise the I3C traffic. So click on the load button. I will just load the preloaded scripts. ENTDA script. So this script is to send the broadcast enter dynamic address command, ENTDA CCC. So this script is sending at the frequency 500 kilohertz with a duty cycle of 50% duty cycle. And we have the various timing parameters here. So user can vary the setup time for repeated start condition and setup time for stop condition and clock after start condition. So all these parameters are in terms of nanoseconds and the frequency is in terms of kilohertz. So the maximum frequency is 12.5 megahertz all the way down to 1 hertz you can run. So when you click on run, you can see the decoded result. The command has been decoded. So in the selected frame view, we can see the in detail frame format. So if you see here in the PID value, the target has responded with its PID and the BCR and then the DCR value of the target. So then the controller has assigned the dynamic address 8. And go back to the network and we can see the dynamic address 8 is assigned to the target. So now you can controller can communicate with the target with a dynamic address of 8. So similarly, we can run the scripts, different scripts, like I'll just load one directed read command where it will read the PID and BCR and DCR value of the target. So I will edit the node to 9 since I'm communicating with the external target device. Click on run. So the command sent are decoded in the decoded result. So when you click on this, the corresponding waveforms will get updated. And in the plot view, we have the options for zoom in, zoom out, pan, feedback to screen, and if user can also place the cursors and measure the values. So if they are interested to measure the clock to data delay or the repeated start condition, you can just place the cursors and measure the time. So here we can see the value. User can also save the image of the plot so that it will include in the report generation. Similarly, you can do a str write read operation. So I'll load the private write read command. So in this script, I'm writing to the register address 10 with a data byte of 2345 and reading back from the register address 4 bytes. So here we can see the private write, then a private read followed by a repeated start, read has occurred. So we can see the data has read from the target. So we do support the error injection from S0 to S5 error. I'll just show the command parity error and data parity error. So error C stands for command parity error and error D stands for data parity error. So here we can see S1 error has occurred. So that means the command parity bit of the command is wrong since we have inserted the error. So next followed to recover from the S1 error, the NAC followed by HDR exit is. So controller has sent the NAC followed by HDR exit in order to recover from the S1 error. Next, I'll send the error D, data parity error. So here we are inserting the parity bit error in the data field. We can see instead of 0, it is 1. So similarly, other features like the tool supports search, filter in, filter out. Then you can set the markers and measure the timings. And you can generate the report. You can generate the report in HTML or CSV format. Also, all these captures are recorded in the default path. So user can load the capture trace file at later point. Yeah, this is all for the basic I3C demo. So I'll now switch to MCTP demo. Now I have connected an external SSD to validate MCTP protocol. Proceed to add the devices. So this device setup is I'll add a controller, internal Prodigy controller. Due to the time constraint, I will be loading the saved network configuration, which includes one controller and one external target device with a DCR type set to MCTP. Then I'll click on controller to send the MCTP traffic. So initially I will be sending the broadcast ENTDA CCC command to assign the dynamic address to the target. So here you can see the dynamic address 8 is assigned to the external target. So some of the SSD may require dummy cycles to respond for I3C command. So in that case, you can just send multiple times the broadcast command. Then it will acknowledge for the 7E address. I will perform the basic MCTP initialization process. So that is, which is get MCTP version, then setting the endpoint ID and getting the endpoint ID back. Sorry. So I'll perform the MCTP initialization procedure, which will include first from the controller, it will send the get MCTP version, then a set endpoint ID, followed which again get endpoint ID. So before setting the controller request for get MCTP version, I will configure the IBA response. That is, whenever the IBA is triggered from the target, the controller should read the response from the target. So now I will load the get MCTP version command script. So this script basically is for sending the get MCTP version. So here you can see the HDR version, that is the header versions is set to 1. Then the destination ID, then the source ID, then SOM and EOM, then packet sequence, tag owner, message tag. These are as per the MCTP header. Then IC bit is false, and then the MCTP control, and the request is true, and the datagram is false, followed with the instant ID is 0. Then I have selected the MCTP command as get MCTP version with the data payload of FF. So I'll send this request. Now you can see the target has responded with the get MCTP version, the version of the MCTP version. Next, I will set endpoint ID, where we can set endpoint ID to the target. So here I am setting a AB as a value. So when you send this command, we can see the response for the set endpoint ID. Thus, we have set the endpoint ID as AB, and if you see in this completion code, we can see a success message. So that is sent success. So we'll try to read this get endpoint. So this is the result for get endpoint ID. We can see again this is a command code that is for get endpoint ID, and the completion code as 00, and the MCTP data, it returned the whatever the endpoint we have set it AB. So similarly, you can send any of the MCTP commands to the target and see how it responds. Whether it returned with a successful, or it says that unsupported command, or any other generic error like invalid data. So we can see in the completion code here. So this is the scripting for MCTP EXPD. So similarly, we can do a NVMe exerciser by choosing the MCTP message type as NVMe. So now I will do a NVMe transaction, that is NVMe over MCTP. Then we can select the corresponding commands, like I'll just select NVMe command and we'll do a read NVMe data structure. Read NVMe data structure with the data D word 0. We need to enter a D word 0 and D word 1. For a NVMe command, the IC bit should be true. That is the reason we didn't got the target has dropped the response. So I have not received any response for the when I set a IC bit as true. So now I have reverted the IC bit to true. Now we'll send this command. So you can see the response saying a success or the read MCTP, read NVMe data structure. These are the responses, and the last four is the NVM message integrity check. That is a 32-bit message integrity check, and the last byte will be picked and then a stop condition. This is the NVMe-MI message command. Similarly, we can send a NVMe control primitive as well as admin command. So in that case, the NVMe message type, we can just change it to control primitive command. So control primitive command, and we can set rest of the commands. So here that is a about command. So now I'll send this command. So you can see the about and with the response of success. So if you have entered a wrong payload value or the invalid size, we can see the command, the response we received as a invalid command size. So similarly, we can try sending a error in the header packet as well, and then it will return, either it will silently drop the response packet, or it will show a messages like invalid command size, invalid input data size, or invalid opcode. So some of the reserved commands the SST won't support. In that case, we will get an invalid command opcode status. So this is how a MCTP and NVMe commands can be sent over the I3C EXPD software. Yeah. Coming to the conformance test suite, Prodigy supports I3C, MCTP, and NVMe and SPDM CTS test cases. So to test conformance test suite, I'll just click on CTS, and here you can enter the target configuration like organization name, project name, and DUT type, DUT version, and the DUT description, and the test engineer name. And you can also include the report, and this information will be present in the report generation. So I'll click on submit. So we have to configure the controller and the external target. So I have already added the controller and the targets in the network. So I'll directly click on configuration done. So here we have the options I3C, MCTP, and SPDM. So now I'll click on MCTP to test the MCTP conformance test suite. So here this is the MCTP test cases defined from the UNH document. So group 1 and group 2 and group 3 are for the MCTP test cases, and from the group 4 it starts the NVMe test cases. So all these are NVMe mandatory test cases we are supporting. So these are all the NVMe test cases. So in this panel, we can see the sys configuration. So user can select this, adjust the system timing parameters like the frequency or the setup time for start and stop. We can adjust here and send the commands. So here we have the option of select all to run all the test cases in one shot, or user can individually select the test cases and run one by one. So I'll select group 1 and group 2, group 3. So this is for MCTP test cases, and send button to send the test cases. So now we can see the initial that broadcast reset DA and ENTDA command has been set. Then the MCTP initialization, that is the get MCTP version, set endpoint ID, get endpoint ID. So in the decoded result, we can see the test cases name, the corresponding test cases. So these are related to the test case 1.1, 1.11. So now we can see the target is responding for all the test cases, and we can see that all the test cases are marked as green, the tick mark. So we can see when we click on show frames, where in the decoded result, it will get highlighted. That means that particular frames are related to that test cases. So we can see like this is so in the failure case, here it will show a failure case saying that it is the response is not proper, it's expected a success, or get endpoint responses. So the test case which is marked in fail, it's the test cases, the failure test cases will be marked as red, and it will show the error description as well. So these test cases are basically for saying the bad packet. That means you are purposefully changing the set OM, that SOM bit and EOM bits, and seeing whether the target is able to respond for that. So now if you take one example, like if you see here in the test case 4141 get endpoint ID, the SOM and EOM is set to 0. That is why the target has not responded for this packet. So in the next get endpoint ID, the SOM and EOM packet is true. That in that case, the target has responded. So these are the test cases. These are one of the test cases defined in the specification to check MCTP bad packets. So there are different test cases. Test case for MCTP, prepare for endpoint ID, get endpoint ID. So you can also generate a report. So in the plot view, we can see the corresponding frame. So when you click on that, the corresponding plot view gets updated. So we can analyze the data frame format. So we can also generate the report. So in the report as well, you can just, we can see the device list, all the information, what we have configured while running the test cases, and then the summary. That means the 14 test cases we have selected and 14 test cases are passed. So here we can see the in detail protocol list. You can generate the report in either in HTML format or CSV format. So click on send, select the NVMe test cases and click on send button to run the NVMe test cases. So MCTP initialization will be sent first, then NVMe invalid opcode check will be there. That means for the commands which are reserved, the target will respond. Target will respond with the invalid command opcode. And the next test case is for invalid parameter check. So as I said earlier, the marked red will be shown as fail. Sorry. the failed test cases, we can see the error. The request response code did not match. It was expected as success. So we can go back to the test cases and see why the VPD read we got a response of invalid parameter. So in this way, we can analyze the target operations. So the red mark will be highlighted in the decoded result as well, so which will help in debugging the issues. Yeah, I have run total 10 test cases of NVMe, out of which 7 got pass and 3 got failed. So we can see the pass and failed results. So this is for NVMe CTS test case. Moving forward with SPDM EXPD demo. SPDM, that security protocol and data model, establishes a secure channel between the host and device through a structured handshake. So let me begin by connecting and configuring the devices. So I'll connect and then add a controller. And here I will be configuring the Prodigy's target itself. So where the response I am sending manually from the custom data. So I'll choose a DCR type as MCTP. So internal Prodigy target won't automatically respond for the commands we are sending using a response. Sorry, the response data is sent using the custom data. I'll start the capture, then issue a dynamic address assignment command, that is ENTDA. Next, I will send the MCTP response data. So this is how the scripts look like. So this till here, there is the MCTP header format, which include the destination ID, SOM, EOM, and all. Then in message type, I will choose it as SPDM over MCTP. Followed by that SPDM version, then a request response code, that is get version, then the param1 and param2 fields. So this the SPDM process begins with sending the version negotiation, followed by exchanging capabilities and agreeing on cryptographic algorithms. Once both sides align, they perform a key exchange to generate a shared session key, and finally trust with a finish message. So all those commands can be sent from selecting from the drop down, like challenge, chunk, and digest. So all these commands are listed in the drop down. So you can just choose the corresponding command in the request response code and form a command and then send to the target. So here I'll just choose get version and param1 and param2 as 0. Then I'll click on send. So now the SPDM over MCTP, that is a get version, has been sent, and to that we get the response as version. And here we can see the SPDM version as 10 and request response code as 4. So followed by that, we can see the version number entries. So similarly, I'll just load the other commands like get capabilities. Then I click on run. Then I'll click on run and we will get the get capabilities. So this is a response for the get capability. So capability we received. So here the request response code is 61. So along with that, other parameter or the flags we can see here in the selected frame view. So similarly, all the SPDM commands can be sent over the software. Similarly, all the SPDM commands can be sent through the script. I'll switch to CTS. So from the drop down, I'll select SPDM. So these are the test cases for SPDM CTS as per the conformance test suite defined by the DMTF. So test case Prodigy supports case 1 to case 16. So these test cases include testing of various SPDM commands such as version, capabilities, algorithm, and digest certificates on. So user can individually select the test case, or user can select multiple test cases and run. So for the demo purpose, I will be selecting few of the test cases. And next, click start to start the acquisition and click on send to run the test cases. So now you can see the test case has run, and we have received the response for get version as version. So next 2.1 test case is for capabilities, that is verifying the capabilities. So I'll click on show frames, and you can see the highlighted portion is corresponding to that test cases. So initially the get version, then the capabilities. So next 2.2 test case is for to verify the version mismatch. So if you get any version number mismatch in the command, so the response will be the error. So if you see here the capability, and we are sending it the SPDM version of 40, and we have received a response as error as per the specification. So in case if you get any wrong response, so it will be marked as wrong. So the highlighted in the red will test case 2.3 got failed because of the request response code did not match. So it was expecting a capability. So it will be highlighted and displayed over the UI. So using this, user can validate the SPDM test cases as per the specification. Yeah. The next protocol application which Prodigy supports is PLDM, that is platform level data model. So user can load the PLDM scripts. Yeah. So here when we send the get PLDM version, we will get response back saying that the command has successfully completed or not. So we can see the completion code as success. So similarly, we can load some other PLDM commands. So I'll just send get TID. So this is the response for get TID command. So next I'll send set TID value. So it will set the TID. So basically you can send all the PLDM messaging control discovery commands using the Prodigy software. Thank you.
So if you look at this is a one product, Prodigy's PGY I3C EXPD, which supports all the different protocols and its application layer protocol. I3C, I3C CTS, I3C multi-lane, like dual lane or quad lane, it is all configurable. SMBus, bulk transfer, I2C support, MCTP support, MCTP CTS, NVMe-MI CTS, SPDM CTS, and PLDM. So this is a field upgradable. Based on your requirement, you can buy a configuration today, and you can later on upgrade it as and when your requirement is changing and to adopt the new standards. It has a strong pedigree for this product because of the large install base, because we have been continuously getting the feedback, and we have been incorporating in our product to making sure the product is working reliably for a long period of time. And we have been continuously investing on this product since the inception of I3C protocol standard. So if you have any questions now, you can post that and we would like to take up.
Thank you, Godfrey and Shweta, for that insightful session. Let's move on to the Q&A session. The first question is, does Prodigy I3C Exciser and Analyzer supports HDR built mode transfer?
Yes. So Prodigy I3C exercise and protocol analyzer, high data rate bulk transfer mode, so that you can try a lot of data to your target. It is supported.
Okay, thank you, Godfrey, for answering that question. The next question is, does the Prodigy I3C Exciser and Analyzer supports multi-lane and whether it is field upgradable?
Yes, that's a very good question. So our hardware is already capable of I3C multi-lane. All the necessary hardware is built in. You can upgrade your hardware in the field as and when you are adopting the multi-lane standard. We will provide you the new firmware as well as software to meet your requirement when you upgrade the I3C EXPD for multi-lane support.
Thank you, Godfrey, for answering the question. The next question is whether Prodigy Technovations offers basic I3C protocol exciser analyzers for field debug, especially for manufacturing purposes.
Oh, that's another good question. We actually have a I3C EXPD Lite version, which is half the price of I3C main unit, which provides the basic protocol I3C exerciser and analysis capabilities like SDR, HDR, and IBI hot joint capabilities, which can be used. And also we have a I3C USB adapter, which can be used for production testing, where you can do the complete automation of your testing at the 1/4 the price of PGY I3C EXPD for your manufacturing test purposes.
Okay, thank you, Godfrey.
Thank you, and thank you for taking time out to attend this session. Please do write to us if you have any questions, and you can always reach out to our channel partners across the different geos, as well as you can write to us at this email address. Thank you and have a great day. Bye.